It turns out that there are several ways to define multiplication between vectors. In this section, we're going to discuss the dot product. We'll begin with the definition. Definition: the dot product of the vectors u and v in Rn is a scalar quantity u dot v is equal to u1v1 plus u2v2 plus plus un_vn. At this point, this is just a formula. We'll talk about how to interpret the values soon. For now, we just want to make sure that you know how to do the calculation. Notice that we are taking the product of the corresponding vector components and then adding the results together. So if we calculate 124.-230, we would get 1 times -2 plus 2 times 3 plus 4 times 0, which is 4. Notice that the output of this is a scalar. For this reason, this is sometimes called a scalar product. The dot product satisfies certain properties. We won't go through the proofs carefully in this video because it's just plugging things into the formula and doing a little algebra. If u, v, and w are vectors in Rn, then the dot product is commutative, it distributes over vector addition, and the dot product has a property that looks similar to the associative property, but technically isn't. Just as with the previous section, these properties point to some foundational concepts that are useful in proofs and derivations. But we're not going to spend time discussing them in the abstract. However, there is one property of the dot product that we will discuss in detail. It turns out that the dot product of a vector with itself is an important quantity. Let's look at the dot product of a two-dimensional vector with itself. After writing it out, we get a result that should seem familiar. You might recognize this as the square of the magnitude. This property holds true in general. The dot product of a vector with itself will always give you the square of the magnitude of the vector. This fact is used very frequently when working with vectors, especially in proofs and derivations. So it is important to have this fact at your fingertips. Now that we have a few facts about the dot product, let's take a look at what it means. The best way to do this is through the derivation of a geometric property of the dot product. If we have two vectors with their tails together, they will form an angle that is between 0 and 180 degrees. We'll call that angle theta. By connecting the tips of the vectors, we create a triangle. We'll leave it as an exercise to convince yourself that the third side of the triangle is the vector u minus v if we draw the arrow from the tip of v to the tip of u. Now we have a triangle with all three sides and one angle labeled. This is a situation where we can apply the law of cosines. The law of cosines uses the squares of the lengths of the sides, which we can rewrite using the dot product. Notice that in the difference term, we have to use the distributive and commutative properties of the dot product to move forward. From here, we can do some canceling and rearranging to simplify the equation. You can pause and look at the details, or find the details in the book, but they're not difficult manipulations. It's just following the algebra. In the end, you get this formula. The dot product of the vectors is equal to the product of the length of the vectors multiplied by the cosine of the angle between them. This is often written in two other forms, solving for either the cosine of the angle or the angle itself. This shows us that the dot product is related to the angle between the vectors, and we even get an explicit formula for the angle. It's important to remember that this is the formula for the angle between the vectors when they are drawn with their tails together. There are many errors that can result from not checking that. Let's take a closer look at the dot product formula. Notice that if the angle is pi over 2, then the dot product is going to be 0. In other words, if the vectors form a right angle with each other, then the dot product is 0. There's a special term we use for this. Two vectors are said to be orthogonal to each other if their dot product is 0. For this class, we can use the words orthogonal and perpendicular interchangeably, but there are other applications of vectors for which the word perpendicular ends up being geometrically confusing. And so the preference when working with vectors is to use the word orthogonal when the dot product is 0. We can actually discover more about the dot product from this formula by thinking about the behavior of the cosine function for different angles. Notice that if the angle is acute, then the cosine is positive, which then means that the dot product is positive. If the angle is obtuse, then the cosine is negative and the dot product is negative. This means that the sign of the dot product tells us whether the angle between the vectors is an acute angle, a right angle, or an obtuse angle. This is a useful algebraic tool to have when thinking about the geometry of vectors. For the next video, we're going to look at some applications of the dot product.